Our next section is logarithms, so with stuff that you have not seen yet. So logarithms as an inverse. So what does it all mean? First, if I had a problem like this first one, 7 raised to the x is equal to 49. A lot of people would be able to say, oh, well, x is going to be equal to 2. Because when I square 7, it's going to be equal to 49. Well, that's true. However, what if I had a problem like this? 7 raised to the x is equal to 32. Now, that's not going to be a whole number. So that's where we have to have an inverse for your exponent. So the inverse for an exponent is a logarithm. And so first today we're going to just talk about the basics of logarithms. How you can rewrite a logarithm into an exponent and an exponent into a logarithm. So I'd make sure to write down this box part right here. Make sure to write this down. In both cases, a log has a base, b. So that's this little b here. It can be of any number, and it could equal any number. Now this log base b is always going to be the same as if I had b base raised to the y power is equal to x. These are going to be interchangeable. You could rewrite one as an exponent or rewrite a exponent as a log. So that's what we're going to practice right now, is rewriting each equation as a log. Again, when I look at this equation, the whole number as an exponent, that's your base. So in this case, I would have a log base 10. The number that it's equal to is like your x, so it would be log base 10 of 100 is going to be equal to 2. So the exponent is what it's equal to. Right now I want you to pause the video and attempt the other 5 problems by yourself. The second one, you should have got log base 2/3. Again, this is going to be your base. As an exponent, whatever number is raised to the number, that's your base. And as a log, it's always the little number by the log. My other 4 problems should be log base 6 of 36 is equal to 2. Log base 3 of 81 is equal to 4. Log base 3 of 1 is equal to 0. Pause the video and I want you to try to write these logs as an exponent. Again, the base does not change. So here's my base of my log, so that's going to be my large number. And here's what it is equal to, so it would be 2 to the 7th is equal to 128. And the second one, here's my base, so that's my large number. 7 to the 5th is equal to 16,807. So that's how you write your log as an exponent. Again, the log is the inverse or the opposite of exponent. For this next problem, I don't have an equal sign. So I'm going to say this is equal to x. I want to find out what log base 8 of 32 is. And we will get into other ways to solve this problem throughout the chapter. But right now, I'm first going to rewrite this as an exponent. So here's my base. I'm going to leave that as my base. 8 raised to the x is equal to 32. Now I know 8 squared is 64. So one thing I'm going to do is rewrite 8 so that it's 2 to the 3rd is equal to x is equal to 32. Now I can use my properties of exponents. One thing I can do is rewrite this as 2 to the 3x is equal to, and I can also do my factor tree here. So once I do my factor tree, it looks like I have 1, 2, 3, 4, 5, 2. So I can write 2 to the 5th is equal to 32. Once you have the same base here, once you have the same bases equal to each other, I can say 3x is now equal to 5 because of the same base. So this is going to be equal to this. Your exponents will be equal if your bases are equal. So now if I solve for x, I just have to divide by 3 on each side, and x is going to be equal to 5/3. So 8 raised to the 5/3 power will be equal to 32. First step for A, B, and C that I want you to do right now is to rewrite it as an exponent. So these would be your numbers as an exponent, and then I would want you to write each side of the function in smallest exponential. So example would be rewrite this as a power of 5, rewrite both of these as a power of 2, just like we did in the previous problem, and rewrite both of these as a power of 2. So for this first one, since they're both a base of 5, they both have a base of 5, that means I can put their exponents equal to each other. So x is just going to be equal to 3 for this first one. For the second one, they both have a base of 2, so I can put my 2x is equal to 5. So 2x is equal to 5 divided by 2, x is equal to 5 halves. And for my last one, they both have a base of 2, so I can set my exponents equal to each other. So 6x is equal to negative 5 divided by 6. X is equal to negative 5, 6. So those are my 3 final answers. Make sure you took great notes and have a wonderful day.